take another look at the problem we were seeing yesterday, but I also want to introduce a new concept. We were doing what we could call a specific instance of a more general problem. Now, generality versus specificity we might think of on a spectrum. So something very specific would give you a specific function with real numbers that you probably feel comfortable with because you know how to use these numbers. It's also nice because you get a directly applicable answer when you're dealing with a specific instance. Of course, at the end of the day, you're always going to want a specific answer to a specific problem. But with a general approach, what you're doing is you're encapsulating a lot of problems all at once, and you're essentially solving all of those problems. So I'm going to look at yesterday's problem taking a more general stance, not as general as just the price is some function of Q, which is as general as we could get, but I'm going to use a simple linear form, same as y equals mx plus b, right? In this case, it's going to be price equals bq plus a for the demand, or the way I've got it written here, a plus bq, and supply is c plus dq, right? So any supply and demand problem following this format, we are going to solve. We're going to solve actually two things. One is we're going to find what is the equilibrium quantity and what is the equilibrium quantity given a tax. And we'll see at the very end, that's also going to cover what is the equilibrium quantity if we had a subsidy. So this is our general form, and I put this little PD here just to distinguish the price that the consumer pays versus the price that the seller gets. So we'll think of P as what is the actual price on the shelf, and PD is essentially what is the price on your receipt. So the way to think about that is the benefit you're getting from this product, you're willing to pay whatever the sticker price is plus the tax. If you get $30 of benefit and it costs $30, you're breaking even, you might buy it, you might not. But if it costs less than $30, you're happy to buy it in that case. But let's say it costs $28 plus a $5 tax, well, in that case, you're not going to be willing to buy it again. So we've got this general setup, the price for the seller, we're just taking the default supply curve, and here we're thinking about this as what is the price as it affects the supply curve plus that tax. That's what's going to put us back onto the demand curve. Now we could think about this another way. So what we're essentially doing here is we're saying, let's treat this as though the buyer has to pay a tax. So I buy a Mr. Potato Man for $16, and then I also have to write a $1 check to the New York State government in the form of sales tax. Now in practice, I bought Mr. Potato Man on Amazon, and Amazon just collected the money. It was all part of the same thing. I saw $16 plus a $1 tax. They handled all the accounting work, but we can think about this as shifting our demand curve down by giving me this obligation, right? So I get the good thing, I get what I really want, plus I get this bad thing, which is I have to give away a little bit more money than I was ready to begin with. Right, so essentially shifting down the demand curve. And that's going to move us to an equilibrium point here, right? So we're going to have what's the price, and then we throw the tax on, and that's going to determine what is the quantity demanded. The other way we could think about this is rather than having the benefit plus this negative benefit from a bad thing, from this tax you'd rather not pay, we could think of this as supply tells us cost, plus this extra cost of Amazon has to collect an extra bit of money and send that back to the government. So if they got $17 from me, but they have to send $1 to the government, not because it was required to process the goods, not because it was required to run their offices or to produce the product or to ship it from overseas, but because there is this extra legal cost in the form of an obligation they have to pay. And we are still treating this as just a per unit, right? Something T. We could think about this as a percentage, and then we would just want to change the form that we've got over here. So in that case, we might say P times 1.0825 to get New York State sales tax. And we'd essentially solve it in the same way. But for now, we'll stick with the relatively simpler one, and I'll leave that. Actually, let me set you up with that if you want to work on this in your notes. So if we have a percentage tax, you could call that price times 1 plus the tax rate. So 1 plus t, where t is something like 0.05 to represent a 5% sales tax. So with that, you can pause the video and try and solve it, or you can stick with me while I walk through the simpler version where we're just saying something like $10 per unit. So with that said, let's go ahead and move over here. I don't need to know demand and supply, and I'm going to replace this PD with P plus T. Sorry, I actually lost myself on a digression. The supply side, well, actually, no, I think I mentioned that, right? We're essentially adding that extra cost, which shifts us to here, in which case the price after tax. As a real world example, again, to pick Mr. Potato Man, there's the sales tax I paid when I bought this, but there were also the people working at the factory who were paying income taxes. So indirectly, I was also paying for that tax, which I saw in the form of a higher price than would have been the case without that tax. So as a consumer, I just see the higher price, but the suppliers see, hey, I was selling labor, I collected a certain amount of money, but my take home is smaller than that. All right, so in either case, we're getting the same thing, but really what we need to do with this is just create some gap between the quantity corresponding with the price the seller gets to keep and the quantity corresponding with the price that the buyer has to pay out of pocket, right? So it's the whole thing. The sticker price plus the tax is the price out of pocket, right? Or we could think about there is the sticker price if we've included the tax, and then for the seller, we could say PS is going to be the take home, which would be the price minus tax payments. So you make $1 million, but you got to pay $100,000 tax. You're bringing $900,000 in on net, and that $900,000 is what matters for your costs when we take account of that tax. All right, so we've set things up. I'm going to do a little bit more, and I'm going to pick up the camera once I solve this and show you what we're doing, because I know the quality is not great on this camera. So let's go ahead and take this. This is our basic setup. I'm going to move the T over so that I've got P equals stuff and P equals stuff, and then I can just directly solve for Q. So I've got C. Let me get a better marker. I think the brown we can see. And let me come at this from here. C plus DQ equals A plus BQ minus tax. Now, like I discussed in class, sometimes it can be tricky to figure out where to put the tax in this setup. So it's worth remembering that sometimes you just make mistakes, and that's fine. You make mistakes, you learn from them, and then you try again. For me, I've made these mistakes, but I make them at the beginning of every semester because, if you're not using it, if you're not using this algebraic practice, you get a little bit rusty, and that's where I am every September. So, supply equals demand. Now we solve for that equilibrium quantity. I'm going to keep the Q over here. So I will subtract BQ from both sides. I'm going to move the C over. So I'm going to subtract C from both sides. And that's going to give me DQ minus BQ. Right? C's cancel out. We're left with this. BQ's cancel out. So here we've got A minus C minus T. Now I can factor out, I can factor out the B and the D. So Q times D minus B equals A minus C minus T. Subtract both sides. And I get Q equals A minus C minus T all over D minus B. This gives me our general solution. Now, if I take this and I plug it back into either one of these, it's going to give me the price. So let's go ahead and look at a feature of this before we go much further. So this is sort of a preview of something we're going to see later in the semester. This is essentially what calculus is dealing with. We want to know what is the change in quantity that we should expect if we change the tax. And what we see here is if we have a tax of 0, well, this doesn't matter, right? And when we plug in our specific formula to this, this solves down to Q equals 150. You can verify that on your own. Just plug in A is 800, C is 50, D is, what was it? I think it was +2 and B was -3, but I might have those confused. It might be +3 and -2. But because of this negative sign, the bottom is going to turn out to be 5 with the problem we looked at yesterday. In any case, what we can see is if we increase t, this side of the equation becomes smaller because we're subtracting away. That means we're getting a smaller quantity as we increase tax, which is good. This means it's passing our first smell test. This looks like it matches our basic problem. Now, other things we can look at here. Let me draw that supply and demand curve again. We had, from the demand side, we had A, and our slope was B. And then over here we had C for our supply curve, and our slope was D. Ooh. I did not get good grades in penmanship, which, well, now it's your problem. So we have A and D. So what we should expect is that A is greater than C. If C was greater than A, that would mean our supply curve is up here, which would mean we don't have a market. Right? That might be the case if we think about the market for vacations on the moon in 2020. Much as I'd like to go, the cost is greater than my benefit, so there's just no market at all, right? There's no equilibrium on the positive side of the quantity. We might make an equilibrium in the mathematical model that says there's a negative equilibrium quantity, but of course there's no such thing. So A greater than C, that means that whatever this value is, it's going to be a positive, and it's going to get smaller if we add more and more tax. And then this, D is positive, minus a negative means that we're essentially adding a value to this. We're going to get a positive value on both sides. So what we've got is something greater than 0 over something greater than 0, which means our quantity is going to be positive. We have a real quantity that is possible as long as those numbers fit our intuition that we've embedded in this setup. All right, so let me just really quickly plug in these numbers. We can verify that it works with yesterday's question. So, still have too much glare, but we'll make do. So we plug in A was 800, C was 50, and the tax was 10, all over D minus B. So D was 2 minus -3. Like I said, maybe this was -2, but you switch that, it's going to be the same. So we have 750 minus 10 over 5. And if we just look at 750 divided by 5, that's going to be 150. That was our equilibrium with no tax. When we put in this $10 tax, that's going to turn into a quantity of 148. And we plug that in, and we're going to find this price on the supply curve. All right, so if you didn't try this, I recommend this. This is something you should think about for the midterm. If we have a percentage tax, we're no longer saying the price to consumers is T dollars higher than the price to sellers. Now it's going to be T% higher. And here we're thinking T is something like 0.05. So with that, try and figure out how this varies for a percentage tax. And basically what it's going to do is we're going to sort of rotate this curve. Right? So for a really high price, we're going to have a big gap. For a low price, that gap is going to be smaller, but it's always going to be the same percentage. So let's take a look at what we've got. So when we're thinking about demand, we're thinking about what is your out-of-pocket price. That's what really matters. If we're thinking about a supply side tax, we'd think, what take-home money are you left over with when we subtract your tax payments from the price you collected from your customer? So our basic setup in blue is what we're thinking about for a per unit tax of $T. In green, this is what I'd like you to do in your notes, is figure it out for a percentage tax instead. So we're saying that price with the tax is equal to our demand curve, and then we'll rearrange to get price equal to all the same stuff. And then we're just going to use the default supply curve if we're thinking about this as a demand side tax. And I'll leave it also for your notes to verify that if we think about this as PS is P minus T and PD is P, so we've got a supply side tax, you can verify that it should work out exactly the same. Here is our algebra for this version. We take our setup, we've moved the tax over to the one side, we do some rearranging, and we're finally left with Q equals A minus C minus T over D minus B. And we know from this very general setup that for a normal looking supply and demand curve, we'll have A and C as our price intercepts and D and B are slopes. And the big concept we're talking about, something that's specific, is giving you specific numbers that are directly applicable, and then something that is general is giving you something that solves all the problems at once, but not necessarily any particular one problem. Then you have to go in and actually substitute values like we do here. And when we do that, we end up with the exact same outcome we had when we dealt with a specific outcome. But now the advantage we have is we've also solved this problem for any supply and demand system that takes this basic form.